Hello, here we're going to do a short explanation about why we prefer radians to degrees, or at least we're going to compare degrees and radians, and I'm going to try to argue why we prefer radians to degrees. Okay, degrees, the number of degrees in a full circle is 360. Okay, 360 degrees, not a terrible number, right? Lots of divisors. You can divide it by half, you can divide it by 6, by 10. But the weird thing about this number is that it was motivated by the Babylonians who realized that there was about 360 days in a year. Of course, the true number is 365 and some odd, but it's close to 360. And so, as sun worshippers, they decided that they were going to put 360 degrees in a circle, 60 minutes in an hour, 60 seconds in a minute, right? This is all thanks to them. Now, the problem with that is that that makes it an accident based on what planet you're born on, right? So if you're born on a different planet that had a different number of days to go around its respective sun, presumably you would have a different number of quote unquote degrees. Okay, what radians do is instead of using the planet you're born on as a motivation, they take something that's more universal or ubiquitous. If a circle has a radius of r, then its circumference is 2 pi r. And this is true regardless of what planet you're born on, right? It doesn't matter where you're born. If you have a length of r, let me get over here and take a different color. Let's take green. So if this is my length r, then that means that if I go 1 radius, 2 radiuses, 3 radiuses, 4 radiuses, 5 radiuses, 6 radiuses, there'll only be a little bit left over because it takes 2 pi, or about 6.28 radiuses to go around the circle. So 6.28 radiuses, this eventually became the units of radians, or 2 pi radians. So 360 degrees is exactly the same as 2 pi radians. They're just a different measurement system, much like how some countries, well, America, measures distance in feet and miles, and other countries, most other countries, do the metric system, meters and kilometers. So if we divide this by 2, that means 180 degrees, what you may have formerly thought about as the number of degrees, or the sum of all the degrees in a triangle. Half of this would become pi radians. So what is the sum of all the angles in a triangle? You might as well just say pi radians. How about a 90-degree angle, one of our famous 90-degree angles, the right angle? Back when you were a child, you may have thought of it as 90 degrees. Now that we're getting closer to the calculus, just take the 180 and divide it by 2 and call that pi radians. Okay, so radians is nothing but another way of measuring angles. And since you know that 180 degrees is exactly the same as pi radians, this gives you a conversion factor of 180 over pi if you wish to change radians to degrees. And flipped over, it gives you a ratio of pi, a conversion factor of pi over 180, if for some reason you wish to cancel out degrees and change those into radians. Okay, so the main motivation is that they're just more universal and therefore they're going to be more useful overall.